Hello, and this video is going to be about the undoing method. Now, the undoing method is a step-by-step process that helps you solve for x in an equation. Now, another way of saying solving for x is to isolate x, and this is a term that we're going to be using repeatedly. Isolate x means solving for x. All right. Now, one of the first things that we need to do in order to solve for x is we need to identify the operations in an expression. So let's go through these operations. Here we have 3 plus y. The operation here is going to be addition. So we have addition. And for each operation in mathematics, there's always an opposite operation. Now, what I mean by opposite is the inverse operation. So the inverse operation of addition is going to be subtraction. So remember, inverse just means the opposite. The next expression we have is 5x. Here we have 5 times x, so the operation is multiplication. And the inverse operation is going to be division. The opposite of multiplying is always going to be division. All right, let's keep going on with the next ones. Here we have r minus 3.9. The operation here is subtraction. And so the opposite of subtraction, the inverse, is going to be addition. Okay, let's keep moving on. Here we have c squared. So the operation here is that we're squaring. Now the inverse operation of a square is the square root. Alright, let's do the other ones really quick. Here we have 1 over 8 times x. Here the operation is multiplication. The inverse is division. The next one we have d over t, which is division, and the inverse is multiplication. And finally, we have the square root. So the square root is our operation. And the inverse of the square root, as you saw one of the previous ones, is to square it. So the square. Okay, so it's very important to know what the operation, to identify the operations in an expression and to know what the inverse operation is going to be. Now, the undoing method undoes or reverses the order of operations in an equation, which, again, this helps us solve for x or isolate x. Now, the way we're going to actually look for use the order of operations, we have to remember to use PEMDAS. Now, PEMDAS is an acronym for the order of operations that is going to help guide us through using the undoing method. So let's go through each of these and remind ourselves what each of these mean. So P stands for parentheses. The next one is going to be exponents. M is going to be multiplication. And D stands for division. A is going to be addition. And S is going to be subtraction. Now, the order starts from the top. So in an equation, we always start with the parentheses. The next thing, the next level is going to be exponents. And notice M, division and multiplication are going to be on the same level. So you can start with either multiplication or division, it doesn't matter. And then finally, the last level is addition and subtraction. Notice these are also on the same level. So you always start with parentheses, then the next level down is exponents, multiplication, division, and addition and subtraction. Alright, now let's go specifically to what are the steps of the undoing method. So I'm going to list the steps first, and then we'll see an example of how we use all these steps. The first step is to start with, and actually what I'm going to do here is I'm going to type these out, which I think will be easier. So my first step is to start with the variable. Alright. Second step is to create a flowchart to build the equation around the variable. Okay, we're going to see an example of what a flowchart is, and finally we're going to work backwards by using the inverse operation to undo the equation. Alright, so those are the three steps. Now let's take a look at an example where we're going to solve for x using the undoing method. Okay, so the first step is to identify the variable. Here the instructions doesn't say, but is to solve for x. So we want to identify the variable, which is x. The second step is to create a flowchart to build the equation around the variable. So we're going to start with x, and we want to go through the process of how do we go from x into this expression here. So we're going to draw an arrow, and we're going to use PEMDAS. Notice we're going to start with parentheses, and so inside the parentheses I have x plus 30. So my operation that I'm doing first is inside the parentheses, and we're adding 30. Alright, when I add 30, that's going to give me x plus 30. Now we're continuing the order of operations. We're done with the parentheses. Everything's done with that. Now we don't have any exponents, which leaves us with multiplication or division. In this case, our next operation is multiplication. We're multiplying by 5. Alright, we're done with multiplication, division, and we don't have addition, but we do have subtraction. So one thing I forgot to do here is, since I'm multiplying by 5, what my expression is 5 parentheses x plus 30 close parentheses. Okay, now my next operation I identified as subtraction, so we're subtracting 18. And so now my whole expression is 5x plus 30 minus 18. Now notice I have everything in my expression written over here now. So it consisted of actually 3 operations. Alright, and all of this is equal to 17. Now this is what a flowchart is right here. Notice the arrows have the operations, each individual operation that we have, and everything that is circled is the expression. And notice the expression gets larger and larger after we add an operation to it. Okay, now we're ready for step 3. We want to work backwards by using the inverse operation to undo. So remember, the first thing that we did is go over the inverse operations, and so now this is where we have to use it. So in order to undo this, we start with 17, and we're going to draw an arrow going the other way. Notice our operation here is minus 18, so the inverse operation is to add 18. Since we started with 17 plus 18, you can use your calculator for this, and this turns out to be 35. Alright, Again, we're going to draw an arrow. Notice that the operation above, we multiplied by 5. This time we're going to divide by 5, which is the inverse. And so since we had 35 divided by 5, and this comes out to be 7. Alright, so we're well on our way to undo the operation here. So we have our last operation, which is adding 30. So the inverse is subtracting 30. And so we have 7 minus 30. And this turns out to be 23, negative 23. Now, since we don't have any more operations, this is going to be our final answer. So x is equal to negative 23. Now, I always encourage you to check your work. So what we can do is take our original equation, and instead of plugging in x, we're going to plug in negative 23. And we can use our order of operations. So we start inside the parentheses, and this turns out to be 7. Minus 18 equals 17. Now we continue on with multiplication since we don't have any exponents. So we have 35 minus 18 equals 17. And finally, 35 minus 18 does in fact equal 17. Alright, so let's do another example. Again, we want to start with the variable. Now notice in this case, we don't have the variable x. It can always be any letter. So in this case, we're solving for m. So our variable here is m. Okay, so now for step 2, we're going to start creating our flowchart. We want to start with m, and we want to list all the operations in order to end up with this expression here. So we start with m. Let's draw our arrow. Again, we start with the parentheses. So we're looking at inside here. But notice we have that m is being multiplied by 1/2 and added by 3. So which one are we going to use first? Well, even inside the parentheses, we still have to follow the order of operations. And notice multiplication comes before addition. So in this case, we are multiplying by 1/2. So what we have, our expression comes out as 1/2 m. Alright, that means our next operations inside the parentheses is adding 3. So our expression now becomes 1/2 m plus 3. Alright, so we're done with the parentheses. And we don't have exponents, no multiplication, division outside the parentheses. And actually we just have one more operation, which is subtraction. So now we have our whole expression, 1/2 m plus 3 minus 5. Okay, so all of this is equal to 2. We're done with our flowchart, and now we're ready for step 3. We're going to find the inverse operations for each arrow. And we're going to start the undoing method. So our first operation that we see here is minus 5. The inverse is going to be add 5. So we start with 2, we add 5, and that's going to come out as 7. Looking at our next arrow, our operation is adding 3, so we have to subtract 3. And so we have 7 minus 3. And that comes out as 4. Finally, our last operation is multiplying by 1/2. The inverse is to divide by 1/2. And so we have 4 divided by 1/2. So you can use a calculator for this, but let me show you a quick way if you don't have one. We have 4 divided by 1/2. An easy way is to keep your 4 the same, change the division into multiplication, and switch 1 and 2. So you want to flip 1/2, which is going to be 2 over 1. Now 2 over 1 is basically just 2, so you have 4 times 2, and that is equal to 8. And so since we don't have any more arrows, we are done with our answer, and m is equal to 8. Now we do want to check our work to make sure this comes out correctly, so we have 1/2 m, which is 8, plus 3 minus 5 equals 2. So 8 times 1/2 is 4 plus 3, which is 7. 7 minus 5 does in fact equal 2. Okay, there we go. Yes, it does work out. So just to recap, the undoing method, we started out with identifying the inverse operations and for each operation that we see in an expression. We also went over the order of operations using the acronym PEMDAS, and we also went over the steps. All right, thank you.